Good morning. Uh, we meet again with this topic, steam system optimization. This is the fourth presentations. And then today we discuss more about the steam system optimization. You have to note that the objective of steam system optimization is the first one to minimize the steam use, of course. This is the main goal of the steam system optimization, minimize steam use. Because with the minimum steam use, we can reduce the energy consumption. And then the second one is reduce system-wide energy losses. As a consequence of minimized steam use, we can reduce energy loss, energy losses. And then there are some other aspect also related to the energy losses. Yeah. Not just only reducing steam use, but many other aspects we have to concern about the reducing energy in the steam system. And then the third one, as a consequence of energy losses, of energy reducing energy consumption, we can reduce greenhouse gas emission, of course. Yeah. As we know that one of the main source of the greenhouse gas is the energy combustion. Energy combustion is the main source of the greenhouse gas now in the world today. So with the reducing of the energy consumption mean we can reduce the combustion process and then we can reduce greenhouse gas emission. And then the fourth one is this is the most important in terms of the industrial perspective, yeah, in terms of the management perspectives. Steam system optimization tend to reduce steam system operating costs. We can reach the economic advantage, yeah, with the reducing of steam system operating costs. And then with the steam system assessment tools, because in this in the next presentation, I talk about the SSAT, stand for Steam System Assessment Tools. This software developed by Department of Energy, United States. And then currently there are this software available in the online, yeah, available in online mode, yeah. But I have the previous model. In the previous model, this software available. You can download the software and then you can install in your computers. But today, they offer the online software for steam system assessment tools. So you can access directly from DOE website. If you talk about steam system assessment tools software, there are some projects, yeah, related to the steam system optimization. There's a number of projects. The first one is steam demand saving. The second one is use an alternative fuel, which is this fuel switchings. And then the third one, change boiler efficiency. We can the objective of change boiler efficiency, of course, to increase the boiler efficiency, not to reducing boiler efficiency. And then the fourth one is change boiler blow down rate. Yeah, the objective of this project is reducing blow down rate. The fifth one, implement blow down flash tank to generate low pressure steam. And then next, change steam generation condition. And then install and or modify high pressure to low pressure back pressure steam turbine. and then install and or modify high pressure to medium pressure back pressure steam turbine, and then install and or modify medium pressure to low pressure back pressure steam turbine, and then install and or modify condensing steam turbine, and then install make up water heat recovery exchanger on condensate tank ventilation system, and then install make up water heat recovery exchanger on boiler blowdown, and then improve condensate recovery, and then flush high pressure condensate to create medium pressure steam, and then flush medium pressure condensate to create low pressure steam, and then implement a steam trap management program, and then implement a steam leaks management programs, and then the last program is improve insulation on steam and condensate line and equipment. There's so many project they offer in steam system assessment tools. So this this quite challenging for us, yeah. And then it is interesting. It is quite attractive, yeah. Because with this software, they provide a lot of data, a lot of existing data, including the estimate cost to implement this project, including the estimate cost to install this project, to implement these projects. So in the next presentation, we will discuss more about this each of these projects. Yeah, the detail of this the detail of each of projects. But first, we have to talk about the fuel itself. Yeah, the fuel itself, because the main operation cost, the major operation cost, or the majority of operation costs of the boilers of the steam system is the fuel itself. Yeah. There are some type of fuel that usually you use in boiler system. Mostly fuel for boiler system is natural gas, yeah, first one. And then the second one is number 2, fuel oil. In Indonesia, we call this the diesel fuel, yeah, the diesel fuel oil, or solar, yeah. In Indonesia, solar or diesel fuel. Number 2 oil and number 2 oil LS, and number 6 oil. Both of these number 6 oil, I'm afraid that we don't have here in Indonesia. I don't know what is the related, or what is the what kind of type of fuel that in Indonesia similar with this kind of fuel, this type of fuel, number 6 oil. So we can eliminate this. And then the next one is bituminous coal. Bituminous coal is the coal that have higher heating value, around 31,890 kilojoule per kilograms, or maybe about 5,500 kilocalorie per kilogram. It is it is called bituminous coal. It is called bituminous coal. And then the other one is sub-bituminous coal. This is coal that have caloric value or net heating value about 23,465 kilojoule per kilogram. Maybe around 4,000 up until 5,000 kilocalorie per kilogram. Yeah. Or we can also call this type of coal in Indonesia is low rank coal. Yeah, low rank coal. It means that this is low rank in the term of the heating value. Yeah, because we have in Indonesia high rank and low rank. Yeah, in term of heating value. And then the last one, we we also use a biomass. Yeah, for example, biomass is the is type of fuel that extract from the plant, from the plant, and then for example, greenwood here. Yeah, greenwood. Greenwood is around. Greenwood have a heating value around 1200. Yeah, 12,000. Yeah, 12,250 15 kilojoule per kilogram. In this table, we have also the typical cost of the fuel and also the unit price in dollar per gigajoule. Yeah, but it is referred to the United States cost. Yeah, maybe it is slightly different in Indonesia. Yeah. It is slightly different in Indonesian situation. And then we have to calculate the steam generation cost also. Yeah, we have to calculate the steam generation cost. The steam generation cost is the first one is we have to find first the mass of fuel or M fuel. We have also the number of cost of fuel itself, yeah, or K fuel, cost of fuel. It can be per volume, for example, dollar per liters or dollar per metric cubic, or dollar per cubic feet, yeah, dollar per cubic feet, dollar per cubic meters, yeah, or dollar per dollar per MMBTU for natural gas, or dollar per ton, yeah, for coal. Yeah, this is the we have to find this first cost of fuel, yeah, K fuel. So if we know the M fuel and K fuel, we can calculate the cost of boiler or K boiler, which means the K boiler is M fuel multiplied by K fuel. M fuel multiplied by K fuel. Mass of fuel multiplied by cost of fuel. So next we can also calculate the cost of steam. Yeah, cost of the steam. Cost of steam is M fuel multiplied by K fuel divided by mass of steam. Mass of steam. So we need to have the measurement to measure the mass of fuel. Also, we have to measure the mass of steam. Yeah, mass of steam. And then we have a problem if there are no available steam flow rate in the system. Sometimes in the small boiler or in the small steam user, there are no available flow meter, steam flow meter. So if there are no steam flow meter, we can get the M steam or mass of steam. So we difficult from that we cannot calculate the cost of steam or cost of boiler.